So for our final project, we are solving transient two-dimensional Navier-Stokes equation using finite element method, and we use the open source software FEniCS to solve it. This is a brief about our problem statement, where we have two plates and the top plate is moving with the velocity which is specified. We assume incompressibility in the system along with zero body force. So our density is constant and there is no body force in the system. And this slide we have the equations and the boundary conditions. This is a brief about the method. We have a 32 by 32 grid and we use triangular elements to solve in FEniCS, and we solve the entire system from 0 to 10 seconds in 1000 steps, and the time integration is using forward difference method, and we have different solvers to solve the three differential equations and their corresponding weak forms. So in FEniCS, they use Corin's method to solve the weak form of the equations, and the Corin's method is basically a predictor-corrector scheme where it predicts the next velocity initially and then corrects it with the pressure correction. So these are the two brief about the method, and also a sample of the weak form derivation of the divergence of the stress is also shown. So after getting the correct pressure and velocity, the equation is solved for a time 10 seconds. And as a sanity check, we also implemented this for known flow, which is the Poisson flow, which is where the fluid is flowing in a stationary pipe where the walls are having no slip condition, and the flow is developed. The fully developed flow is a parabolic flow, which can be seen here. And then we implement once the Poisson flow is we verify the tool. We also implement this in our problem, which is a Couté flow, where we first have the no pressure gradient across X, and this is the corresponding flow where we have the bottom plate is stationary and the top plate is moving with a specified velocity, so which is having a shear flow or tangential flow. Apart from that, we also test the flow profile for different pressure gradients across X, and these are the results. And therefore, in this problem, we solve the two-dimensional Navier-Stokes equation with FEniCS, and we also compare different velocity profiles for different pressure gradients. Thank you.